All right, hello geometry. This is going to be your notes on section 11.4. We are on page 4 in the workbook, so find your hopefully printed workbook and go to page 4. Otherwise, have your notebook ready and please pause the video if you need to. I have already filled in all the vocabulary, so maybe pause the video at this point to fill it all in. What does circumscribed mean? We've seen that word before. It's when a circle is circumscribed about a polygon if the circle contains all the vertices of the polygon. So if I were to draw, let's say, a triangle, that's a polygon, right? And then I would draw a circle around it. As long as every single vertice of the triangle was on the circle, that's called a circumscribed circle. All right, inscribed is basically the same picture. I can say that the triangle is inscribed in the circle because all the vertices touch. So I say the circle is circumscribed about the polygon, but I say the polygon is inscribed in the circle, okay? In today's lesson, we're going to be talking a lot about regular polygons. So we have to review what is a regular polygon again. A polygon is when all the sides are congruent and all the angles are congruent. So everything is congruent essentially. Now this is a new word, apothegm. An apothegm is a segment drawn from the center of a polygon. It's perpendicular to the side of the polygon. Okay, there's going to be a lot of examples in the drawings that are coming up soon, so I will show you an example soon. What is a central angle? A central angle has its vertex at the center of the polygon and its sides pass through consecutive vertices of the polygon. So I drew a square here, or we can assume it's a square. I don't have really the markings, but I drew a square and I found the center of the square, and that's where the vertex of my angle is. The vertex is at the center. And then I went to the vertices of the corners of the square. That means this is a central angle, okay? Now, how do I find the measure of that central angle? This is sort of a formula that we're gonna use just about for every single problem today. So highlight it, put a box around it, whatever you need to remember. 360 divided by n, and I want you to write down that n is the number of sides, okay? N is the number of sides. All right, so let's try an example to make sure we understand the vocabulary. All right, it says, identify the parts of the regular polygon. So given this picture, what is the center? Well, the center is point V, okay? Name a radius. Now, it's tricky because we don't have a circle, but remember that a radius needs to go to the outside of the circle. And if I were to draw a circle around this pentagon, it would have to go to the vertice of the pentagon. So this is not a radius. It has to go to the vertex of the shape. So I can say either QV or RV. Okay, name a central angle. Well, I'm just going to use what's drawn in there. So I'm going to say QVR. I could also say RVQ. Now here's where that new word apothegm comes in. Some people pronounce it apothegm, however you want to pronounce it. Apothegm is when you're going from the center directly perpendicular to the side of the shape. So it doesn't go to the vertice, it goes perpendicular to the side of the shape. So here we would say VW for the apothegm, okay? Now the next one's very similar, so I want you guys to pause the video, see if you can get them right, and then unpause to see if you got them right. The center here is going to be point X. A radius can be either XR or XQ. Okay, apothegm is going to be going from the center to the side of the pentagon, so I'm going to say XN. Okay, a central angle, I can use either RXQ or QXR. Now let's talk about how you would find the measure. Up here it didn't ask for the measure, but here it does. It says find the measure of the central angle. So that's where this formula is going to come into play. 360 divided by the number of sides. So I'm going to do 360 divided by, and I'm counting 1, 2, 3, 4, 5. It's a pentagon. So I do 360 divided by 5. I believe that's 72, but we should double check. Yep, 72 degrees. That means that this whole angle right there is 72 degrees. Okay. As a side note, if I wanted to find just this angle, half of that, I would cut the 72 directly in half, and I would say that that smaller angle is half of 72. Okay, let's move on to the next page. So now we're going to be on page 5. All the way at the top. The top of the table shown is a regular hexagon with a side length of 3 feet, and it has an apothem of 1.7 feet. Okay. What is the area of the tabletop to the nearest tenth? Well, we don't know the area formula for a pentagon, at least not yet. I'm about to show you here in a minute, but what they've shown us is they've taken a hexagon. They've taken a hexagon and they've divided it into 6 congruent triangles. Okay, it's a regular hexagon, so we know that every single triangle is congruent. So I'm going to find the area of just one of the triangles, and then I'm going to multiply that times 6, and that should give me the full area. So I'm going to do base times height divided by 2. The base of my triangle is this piece here, which is 3. The height of my triangle is actually down here. It could be drawn up here, but they drew it down here. It's the same thing, 1.7, and then divided by 2. That gets me 5.1 divided by 2, and I get 2.55. Now that's the area of one of the triangles, but I want to do that times 6 because there are 6 triangles. So I'm going to do 2.55 times 6, and that gets me 15.3 feet squared. Remember to square your units anytime you're talking about area. Okay. All right, now that was using a little bit of creativity on our part by finding the area of a triangle and then multiplying it times 6. But guess what? There's a formula that will help you find the area of any regular polygon. It's 1/2 times the apothem times the perimeter. So there's that new word again, apothem. So that's why we needed to understand what the apothem was and where it was. And then we have to know the perimeter. We have to know the full side length around the polygon. Okay, so let's try to go to example 3. They don't give us a picture, but that's okay. We should still be able to manage to figure it out. It says the perimeter of a regular polygon is 24. So I went ahead and wrote P equals 24. Then it says apothem is 3, so I went ahead and wrote A equals 3. Find the polygon's area. So this is really just plug it in. They've already given us what we need. So if I'm going to use this formula up here, 1/2 times A times P, I'm going to put the 3 here, the 24 here, although because it's multiplication, I could put it in any order that I want. And then I'm going to multiply those together. 0.5 times 3 times 24, and that gets me 36. Now, they didn't give me any units, so I'm going to put units squared. They didn't tell me if it was inches or whatnot. Okay, so that one wasn't terrible using that formula because they gave us what we needed. But let's look at example 5. Find the area of the regular pentagon. So it doesn't look regular, I'll be honest, you guys. I think the figure was condensed or shrunk a little bit. This angle should be congruent to that angle. It doesn't look like it, but it should be because it says regular. So we're just going to fill in what we know, and by the end of all of this, we should be able to figure out what the area is. Okay. How many sides? Well, if you count, you should get 5. What is the central angle? We're going to do 360 divided by 5, and that gets us 72 degrees. Okay, 360 divided by 5. Then we're going to figure out what the side length is. A lot of times it's already on the picture, so you can see over here they give us the side length is 7.5. Okay, now the radius is not as easy. they've given us what's called the apothem from the center to the side of the pentagon. We need to find the radius going from the center to a vertice of the pentagon. So I took this triangle and I rewrote it out here. Now, where did 3.75 come from? Well, the full side length is 7.5, right? And if I draw in the apothem, it splits those two in half. So I did 7.5 divided by 2, and that got me 3.75. So this section here is just 3.75. And then I know the apothem is 4. So look at, I can use Pythagorean theorem to find my radius. So I'm going to do 3.75 squared plus 4 squared equals r squared. This is like our c value in Pythagorean theorem, okay? So I'm going to do 3.75 squared plus 4 squared, and then I need to take the square root of that. And I get r equals 5.48. Okay? Now the apothem they gave us, that's the 4. Remember, that's always the perpendicular piece from the center. Now the perimeter is not terrible to find. We know a side length and we know how many sides. So we can do 7.5 plus 7.5 plus 7.5 plus 7, or just multiply times 5. 7.5 times 5 gets me 37.5 yards. Now comes the whole point of the problem, find the area. Area is 1/2 times the apothem times the perimeter. The apothem we found, or we were given, was 4. The perimeter is 37.5. So we multiply all that together, and this is our final answer. That's the area of the pentagon. Okay? All right, hopefully you didn't find that too difficult. Let's try another one. This is another pentagon. If I were you, I would pause the video, do it yourself, and then unpause to see if you get it right. I'm going to go through this one fairly quickly because we are given all the pieces that we need, okay? Let me be clear, though, that the 5.29 is only half of the side length, okay? All right, number of sides, we have 5 again. Central angle, I do 360 divided by 5, so that gets us 72. My side length, I have to take the 5.29 and double it, because that's only half of the side. So if I multiply that times 2, I get 10.58. And we are in centimeters here. Now my radius is given to me. Remember, this is the apothem, this is the radius, so that's 9. The apothem is the vertical piece, or the perpendicular piece. Now the perimeter, I'm going to take my side length and I'm going to multiply that times 5. Okay, and that gets me 52.9. Sorry, I forgot my equal sign there. 52.9. Now comes my area. 1/2 times the apothem times the perimeter. And if I multiply all that together, I should get the 192.56 centimeters squared. Okay? Questions on that? Make sure you email or comment on Google Classroom if you are stuck. Okay? Let's go to the next problem. All right. A couple of these are going to require us to do Pythagorean theorem. All right, example 7, it says find the area of the regular hexagon, round to the nearest tenth. Once again, it's giving me everything I need, but this time the 5 is for the entire side length, okay? So this time we have a 6-sided figure, so 360 divided by 6, and that gets me 60 degrees. That means that this angle up here would be 60 degrees. My side length is 5. This time we're in meters. My radius is also 5, again in meters. My apothem is 4.33 meters. My perimeter, if one side length is 5, I'm going to multiply that times 6, and that gets me 30 meters for the perimeter. So my area is 1/2 times the apothem times the perimeter, which is 30. okay? If I multiply all that together, that gets me 64.95, and we are in terms of meters squared. Okay. That one wasn't terrible because, again, everything was given to us. Let's move on to the last two questions. They're considered you try questions, but I would suggest doing this one with me, number one, and then maybe doing number two on your own. It just depends on your level of comfort at this point. I do need to mention this 18 should have been on your diagram, so please add the 18, and it might help to drop down the dotted vertical line there because the 15.59 is only half of the side length, okay? All right, we have a triangle here, so there are 3 sides. I'm now going to take 360 divided by 3. I get 120 for my central angle. What that tells me, you guys, is that this full angle right here is 120, and then if I were to cut that in half, that would be 60, and that would also be 60, okay? My side length, well, they only give me half of it, so I have to take 15.59 and double it, okay? So I'm going to take 15.59 times 2, and that gets me 31.18, and we are in terms of inches here, okay? My radius was something that I had to give you guys, so make sure you drew that in, 18, okay? Now, the apothem is this vertical piece here. I'm going to draw the triangle outside of the bigger triangle, and we know that this is 15.59 and this is 18, and we are looking for this piece, so we can use Pythagorean theorem. X squared plus 15.59 squared equals 18 squared, okay? If you solve that correctly, you should get 9, I believe. Yeah, I'm looking at my answers that I worked out previously. All right, so finding the perimeter is not terrible. We already know one of the side lengths, and we know we have 3 of them, right? This full piece right here is 31.18, so do that times 3, and that gets us the perimeter. Okay, and that gets me 93.54. All right, last part. Area is 1/2 times the apothem times the perimeter. The apothem we got was 9, and the perimeter was 93.54. So if we multiply all that together, we get 420.93 inches squared. Okay. All right, the last one I think is unfortunately the hardest one on here because it does require either 30, 60, 90 or SOHCAHTOA. It's kind of up to you and your comfort level and what you how you wanna solve it. Because notice all they give us is the radius, okay? So we're gonna have to find the apothem ourselves, and we're also gonna have to find the side length ourselves as well. So how many sides do we have? We have 6 sides. Our central angle is going to be 360 divided by 6, which is 60 degrees. Now again, you guys, what does that mean? If I were to draw on another radius, the full angle would be 60, which means that this is now 30 and this is now 30. Okay, do you see where the 60 degrees is? Hopefully. That's why we're going to end up needing 30, 60, 90. We could use SOHCAHTOA if you prefer though. Okay. So in order to find a side length, I'm going to put an X there, okay? We don't know what the side length is, but we have a 30, 60, 90 triangle here. This is 8, this is what we're looking for, and that angle is 30 degrees, okay? So, in fact, I'm going to put an S there instead of an X because that's what we usually use in our grid. So I drew the 30, 60, 90 grid, okay? Opposite the 30 is our S. That's what we're looking for, okay? Now, we know what's opposite the 90, right? Opposite the 90 is the 8. So we have an equal sign in between our 2s and our 8, and we can easily solve that equation. If I were to divide by 2, that gets me that s equals 4. So I can put a 4 there, and that was what I was looking for. Okay, so I'm going to erase my X there, and I'm gonna put a 4 down here. Okay, now guess what, you guys? If this is 4, then over here that's also 4, which means that our full side length is 8. Okay, be careful, I did not get this 8 from here. That's the radius, which we can go ahead and fill in. It just so happens that my side length is also 8 because we got 4 over here and 4 over here. Okay, so the radius was given to us as 8. Now we have to find the apothem. Okay, well, we could simply just use Pythagorean theorem now. Okay, oh, let me briefly go back and show you how to use SOHCAHTOA. If you didn't want to use 30, 60, 90 triangles, looking for this piece here, okay, from the angle, this would be considered opposite, and this would be considered hypotenuse, so that would be sine, okay? So we can say sine of 30 degrees equals opposite over hypotenuse, which is 8. So then multiply the 8 times the sine of 30, and you should have also gotten 4. S equals 4. Okay, hopefully that helped. All right, now let's go back. We know that this is 4, and now we're looking for the apothem, which is this vertical piece here. So I'm going to put an X there, and I can just use Pythagorean theorem. So 4 squared plus X squared equals 8 squared, okay? And if we solve that, we should get that X is 6.93. So that's my apothem. We weren't given any units here, so at the end we'll just write units. All right, the perimeter. I know my side length is 8, and I have 6 of them, so I do 8 times 6, and I get 48. And now my area, 1/2 times my apothem times my perimeter. And if you multiply all those together, we get 166.32, and we are in terms of units squared. Okay, I know that was a long video, but the good news is tomorrow you guys don't have an actual math assignment. So if needed, go back and re-watch this video so that you can get a full understanding on it. Okay, that's kind of why I decided to slow things down, because this is not easy. Okay, please comment with any questions on Google Classroom, or email us to see if we can set up a personal tutoring time. We are here for you guys, okay? Do the best that you can, and we'll check your homework in a couple of days and let us know if you have any questions, okay? Thanks for watching. We'll see you guys next time. Bye.